Okay, now you did some good work with projections and stuff. You got the formula down. There's a reason for the formula. Because I went over it in class, but let's go over it real quickly. Got a vector V. The vector W, then the projection is this vector here. What's known as W of V. Okay, well, if you do this triangle, you have some angle theta here. You're not given that angle. You can determine the angle, using the dot product, but you don't really need it. So you have that triangle here. Okay, and this side is the magnitude of projection. Well, if this is theta, this side has magnitude of V. Magnitude is magnitude of V. So that this side is this times the cosine of theta. Now, if you can't just look at a triangle and see, if you know the hypotenuse, what you do to get this side, you need to think your sine and cosine relationships and triangles, because it needs to be kind of automatic. Not today, maybe not tomorrow, but by the time you get into a statics course or whatever, it better be. Okay. If you do enough of these, then it is automatic. You see, that's a cosine, that's a sine. Hypotenuse times the cosines here, hypotenuse times the sines here. If you want to get into it, this is the side adjacent to the angle, the adjacent side, divided by the hypotenuse is the cosine. Opposite side divided by the hypotenuse is the sine. So your projection is this. Okay. Now, projection is actually this, because the cosine of theta could be negative. In other words, B could be over here, and theta could be more than 180 or more than 90 degrees. Then you have a negative when you do the magnitude of V times the cosine of theta. Scalar projection is magnitude of V cosine theta, and this can be positive or negative. And you want the positive or negative. You don't want to use the magnitude of this side. But I went through the magnitude before I got this, just to relate everything to the triangle. Okay, so W over magnitude of W is a unit vector in the direction of W, right? Okay, so you're going to multiply this magnitude of V cosine theta by the unit vector. Because when you multiply a unit vector by a quantity, you get a vector in the same or opposite direction, depending whether that quantity is positive or negative, whose magnitude is the magnitude of this quantity, and that's exactly what you want the projection to be. Now, magnitude of V cosine theta this. Now, V dot W is magnitude of V times magnitude of W times cosine theta. And that's your definition of your dot product. And you've got to know that. That's got to be second nature. You always come back to that definition. Otherwise, if you use a formula that relies on this definition, like the formula we're going to get here, and haven't related it to that definition, you can't relate it very quickly to that definition, you don't know it yet. Okay? Maybe you can imitate it well enough to get by, but you don't know it and you're not going to be able to use it to solve a difficult, you're going to be less likely to be able to use it to solve a challenging problem and visualize a challenging situation. Okay, well, so anyhow, there we have it. So, different color for emphasis. There it is. It doesn't look like the formula you've been using, because the formula you've been using is a formula used to calculate whether you understand it or not. This formula shows you the unit vector and the scalar projection. Scalar projection times unit vector. In the direction of W, of course. I'm not going to write all that up. Okay, you can compress that. You can do a magnitude of W squared down here and bypass understanding anything. Or you can understand it well enough that, okay, yeah, I know why the magnitude of W squared is there. It's because of the unit vector here. You get a magnitude of W when you do the unit vector. You get a magnitude of W here because of this. Okay. Now that's what ideally you understand about the projection. That's what an A student understands about the projection. Okay. Okay, so there's that. Now let's talk about that parallel pipette.